So here's a harder domain problem about finding the domain of a function where you have a square root and a polynomial inside of it. The key thing is we don't want the denominator to be 0 and we don't want the inside of the square root to be negative. In this situation, what that means is we need that polynomial, that quadratic, to be positive. Now, the way to do this, no matter how you attack it, you really need to know where it's 0 to know where it's positive. So ignore the greater than 0 sign and just think about it when it equals 0. When factoring it, you can solve and find out that x equals 1 and 7 is where it equals 0. And the key thing is what that does is it breaks up the real number line into 3 intervals. So from negative infinity to 1, 1 to 7, and 7 and on. And notice there's no square brackets, so I'm not including the 1 or the 7. And that's because that's where it's 0, and we already know that 0 is definitely bad. So let's just go check the values in each of those intervals. Honestly, all we've got to do is check one value in each, and if it works, the whole interval works. But I'm going to show you on the calculator quite a few points in the intervals on this calculator. So I've already typed in x squared minus 8x plus 7. I'm going to go to the table, and I've got it set up so I can type in my x's. So let's check out x's in this interval from negative infinity to 1. Let's type in like negative 2. Notice that the y value is 27. It is indeed greater than 0. I could type in 0. 0 is included in this, and it's going to be greater than 0. I could type in negative 555, and it's going to be greater than 0. Notice it's actually quite large, but the key thing is it's greater than 0. So we like this interval. Let's look at all the numbers between 1 and 7. Again, all we've got to check is 1 point. So let's check x equals 5. Hit enter. Notice that the value is negative. When you plug in x equals 5, this denominator is negative 8, and we don't want it to be negative 8 because then the inside of the square root is negative. Now again, I could have picked anything in here. Let's check x equals 2. This one's going to be negative also. Negative 5. Let's check x equals 6. That's also negative. So this interval is not good, and therefore we want to check 7 infinity, see if that one's good. Let's go ahead and check 8, and that's positive. So we already know that this third interval is going to be okay, but just to point out, we could do 99. That's a larger thing in that interval, and that's also positive. So the answer that we want is this negative infinity to 1 union 7 to infinity. We did not want that middle interval.